Welcome to the Volumetric Efficiency Training video. My name is Steve Zach, Technical Instructor for Bosch Automotive Service Solutions. I'm going to show you how to diagnose drivability issues quickly to determine whether the vehicle has an air, fuel, mechanical engine, or exhaust issue. Volumetric efficiency testing is the verification of an engine's performance calculated for the amount of air used. Performing a VE test can reveal the accuracy of the vehicle's mass airflow sensor, but more importantly, it can quickly diagnose drivability issues. There are a few things you will need to do before performing a volumetric efficiency test. Find a road that is safe from pedestrians, obstructions, and other vehicles. Then set up your OTC Encore to show datastream readings of the following items: mass airflow in grams per second, intake air temperature in degrees Fahrenheit, and RPM. And then you want to get the engine to operating temperature. Okay, let's go do that road test. Now I'm going to go ahead and start my road test, and from a cruise speed, I'm going to press the throttle all the way to the floor to wide open and then record the highest RPM and intake air temperature and mass airflow sensor readings at the same time. Now we've got to our highest RPM, we're going to go ahead and slow back down and we'll head back to the shop. Understanding the math is not an absolute necessity, as there are calculators available on the internet that we are going to use for this video. We're going to go use the Bosch OTC calculator available at www.otctools.com/VE. Let's take our readings from the road test and punch them into the website calculator and see what our results are. Let's review what could cause VE to be out of specification and cause poor engine performance. To determine the cause of an out-of-spec VE calculation, you need to monitor mass airflow sensor, air-fuel ratio sensor, heated oxygen sensor, and short-term fuel trim at idle with the engine at operating temperature. Most components will use the same test procedure from vehicle manufacturer to vehicle manufacturer, with only a change in specification. An engine mechanical problem would have a test result of very low VE and high short-term fuel trim. Engine mechanical issues can be caused by those components that would cause low compression, such as valve seating, burnt valves, piston rings, cam timing, and cam lobes. Low compression will result with short-term fuel trim adding fuel because the PCM may think the engine is under a load due to lower than normal vacuum. Remember that VE is a calculation of the amount of air going in. With low compression, the engine will not be able to create a sufficient low pressure area behind the throttle plate for the atmospheric high pressure to overcome. To do a quick verification of an engine mechanical issue using the Encore, perform the following test of the MAF sensor. Testing the MAF sensor will help verify that you have an engine mechanical issue. Key on engine run at idle and at operating temperature, the MAF sensor should read 1.4 to 1.6 volts. A second method of verification is to use a vacuum gauge, compressions tester, or cylinder leakage tester. If the vehicle does not have a MAF sensor, go to Global 2 and use calculated load. It will give you the exact same results. So I'm going to start the engine and we'll perform our test. I'm going to tap on datastream. When datastream opens up, I'm going to scroll up to engine data 1. I'm going to tap on customize so I can go ahead and select one item and look at that. I'll scroll up until I find manifold absolute pressure sensor. I'll tap on manifold absolute pressure sensor with a check mark in the box. I'm going to click on apply. We're going to let it open up. Then what we're going to do is we're going to increase the size of our PID because right now it's very small. So I'll tap on the up button. It'll then increase it double in size, or I'm going to pinch it to make it even larger. You'll notice what I'm looking at right now is my MAF voltage is supposed to be with the engine running at idle at operating temperature. It should be between 1.4 volts to 1.6 volts. If you look, I'm running at about 1.45 to 1.46 volts, which means my engine is in good working order, no mechanical issues. In another diagnostic scenario, if you have test results of low VE with low mass airflow readings and high short-term fuel trim, you have a mass airflow sensor problem. This is caused by the mass airflow sensor not reporting air volume correctly. This may require cleaning the mass airflow sensing wire or vane. It could also be a result of additional air entering after the mass airflow in the airstream as a result of a leak in the snorkel. The mass airflow measures the volume of air being consumed. If mass air reports incorrectly to the PCM, actual volumetric flow rate calculation will be inaccurate. Inaccurate mass airflow readings will result with the PCM correcting injector pulse width for a lean condition. Clean the mass airflow sensor wire or replace the mass airflow. You could have a fuel systems issue if you have a VE test results of a low VE and a high short-term fuel trim with HO2S or air fuel ratio reading a lean condition. If my short-term fuel trim reads high and HO2S or air fuel ratio read lean, you have a fuel-related issue. This could be as a result of a dirty fuel filter, could be as a result of a low fuel pump pressure, low fuel pump volume, or a restricted injector flow. Limiting power, creating misfires, hesitation, and other drivability complaints. To verify VE diagnostics and confirm the cause, review fuel trim and then perform tests on heated oxygen sensor and air fuel ratio sensors. So let's go ahead and look at fuel trim. If I look at my fuel trim, you'll notice that I'm probably close to zero. So we're actually at zero right now, which is ideal. We're in good shape. Let's review some of the possible causes of short-term fuel trim that is out of calibration. The specification is 0, which is ideal. Plus numbers on short-term fuel trim means the PCM has received a lean signal from the HO2S or air fuel ratio sensors, and the PCM will command the injector pulse width to widen for a rich correction. Minus numbers on short-term fuel trim means the PCM has received a signal of a rich signal for HO2S or air fuel ratio sensor, and the PCM will command the injector pulse width to narrow for a lean correction. A couple things that we can look at when I'm looking at my short-term fuel trim.
If STFT, short-term fuel trim, reads 0 at idle and positive or plus numbers at 2500 RPM, you may have low fuel volume. If STFT, short-term fuel trim, reads positive or plus numbers at idle and positive or plus numbers at 2500 RPM, you may have low fuel pressure.
To verify that you have a fuel pressure or fuel volume issue, use an OTC fuel pressure gauge. The purpose of this test is to verify the functionality of an air-fuel ratio sensor and test for a possible lean condition. Air-fuel ratio will only function if the AFR heater has reached operating temperature of 1200 degrees Fahrenheit. The engine must be at operating temperature and there must be no DTCs present for the AFR or the AFR heater circuit while performing this test. From idle, you want to raise the engine to 2500 RPM, and it should read the AFR at 3.3 volts in enhanced data and 0.66 volts for global OBD2. Then you're going to snap the throttle to 4000 RPM and the AFR will read 2.5 volts in enhanced data and 0.5 volts for global OBD2. The PCM will then try to maintain positive amperage for a rich condition. After the throttle is closed and the engine has returned to an idle, the AFR will rise to 3.8 volts in enhanced data and 0.78 volts for global OBD2. The PCM will compensate with a negative amperage. This is a lean condition. If there's no change during this test, check for the AFR heater circuit to make sure it is functioning correctly. If we look at this car, this particular car is only reading in amperage. So when I'm looking at a rich condition, I have positive amperage. When I'm looking at a lean condition, I have negative amperage. If your VE test results show low VE and short-term fuel trim is normal or ideal or at 0, you have an intake restriction. The intake restriction could be a cause of a dirty air filter, animals in the snorkel of the intake, carbon on the intake valve throats, any of those types of things that may cause an intake restriction. Part of the VE calculation is the amount of air going in or actual volumetric flow rate. And if there is an intake restriction before the throttle plate, atmospheric high pressure will be blocked, limiting the air needed to overcome the low pressure area behind the throttle plate. To verify the VE results, test the mass airflow sensor. So let's go back into the car and actually test that mass airflow sensor. To verify an intake restriction, test the mass airflow sensor with the key on, engine running at idle and at operating temperature. The mass airflow sensor should read 2 to 7 grams per second at idle. Now slowly increase the RPM to 2500. Now this mass airflow sensor should read 15 to 25 grams per second. If the mass air is below specification, there is a possible intake restriction. An exhaust restriction would have VE test results of low VE and normal or slightly negative short-term fuel trim. This is caused by an exhaust restriction as a result of a plugged-up catalytic converter, or it could be as a result of carbon and exhaust valve throats. Proper VE requires the air to exhaust out. If there is an exhaust restriction to the volume of air required for the engine to create sufficient power, will not be able to enter to the engine. To verify that the exhaust restriction is the cause, you will want to test the catalytic converter. Our last scenario, from inside the car, will deal with a test for a plugged catalytic converter. Using your Encore, select and graph map voltage. When the engine running at 2000 RPM for 3 minutes, know what the map voltage is. It should be around 1.2 to 1.6 volts. Then snap the throttle to wide open from 2000 RPM. Map voltage will rise from 2000 RPM at wide open throttle to approximately 3.8 to 4.2 volts. When the engine returns to idle, the map voltage should return to 1.2 to 1.6 volts in less than 3 seconds. If it takes longer than 3 seconds, the catalytic converter may be plugged. If the map PID is not available, go to Global OBD2 and select Engine Calculated Load PID. With the engine at operating temperature and at idle, record calculated load. Typically, at idle, it should be 20 to 40%. With the engine at 2000 RPM, snap the throttle to wide open. The calculated load will automatically or immediately climb to 100%. When the throttle closes, calculated load will drop to 0%, and it should return to the idle reading of 20 to 40% in less than 3 seconds. Another method of testing back pressure is to use OTC back pressure adapter. If you suspect carbon on the valves, look forward to a new solution from OTC for cleaning the carbon from the valves coming to you very soon. What we have learned from our VE test of this 2014 Mazda 2 is that we have an intake restriction. We came to this conclusion based on the fact that we had low VE and a short-term fuel trim of 0. When we tested the mass airflow sensor to verify this, we showed at 2500 RPM that the mass airflow was reading 8 grams per second, well below spec. When we opened up the air box, we found we had a mouse's nest and we cleaned it out. We hope this video has helped you to understand some pretty technical diagnostic strategies. This knowledge, combined with the OTC Encore, will help you decrease your time in repairing drivability issues and make you more profitable.